Hello and welcome everybody. This is Noah, and in this video we're going to look at some graphs of some rational functions and do some analysis on them. We're going to discuss their domain, their range, and what their asymptotes are. All right, for our examples here, our instructions say to given the following functions in graphical form, determine the domain, range, and asymptotes, both vertical and horizontal. So we need to be defining these things and making sure that we can understand how to view them on this graph. So I'm going to start with just the domain. The domain is any x value that shows up on the graph anywhere. So as I look at this blue line, and as I go, it's not too black, it's hard to see. As I go from left to right, all of the x values, I'm just thinking of the left and right, not the up and down, all of the x values from negative infinity up to, it looks like here at -1, it's not getting to that. It's getting closer and closer to it, but it's not reaching it. And then it has this gap, right? Like there's this gap in here. And that's what we really want to be focusing on. It kind of gets skipped over. As I look at the blue line on the top right, if we come from the right, we can see that the x values go out to infinity. Like nothing gets skipped as we keep going that way. But if I'm coming back to the left, everything's good, everything's good. We're getting all of the x values in there, right? Think of the x, not the y. And then the x values are getting closer and closer to -1, but they never get there. And so we call that kind of behavior a vertical asymptotes. As the x values get closer to -1, they never reach -1, first of all. And the y values are going to plus or minus infinity. They're going up or down. So we see two things right here. We see that the domain is everything up until -1, but not including. -1 is not part of the domain. If we plug in -1, we would get no output. But we can have everything bigger than -1. So the domain is -infinity to -1, and then -1 to infinity. And there is a vertical asymptote that. That's okay. There's a vertical asymptote at x equals -1. So when we see as x approaches that number, the y values shoot up and down, that we call a vertical asymptote. So let's write that down. A vertical asymptote at x equals some number is when as x goes towards that number, the y values go to plus or minus infinity. They shoot up or they shoot down. They could both shoot the same direction. They could shoot different directions. That's okay. But that's how we define a vertical asymptote. And yeah, so generally when we see a vertical asymptote, it's going to be a skip in the domain as well. That's actually not always going to happen. We could do something interesting. We could have a function where a point is filled in on a vertical asymptote, and that would be okay. That's not what happens here, and that's not what generally happens. That's kind of something that you would be forcing in a function if you wanted to. Okay, and now we want to talk about the range and a horizontal asymptote. So for the range, I'm going to go back and kind of retrace our graph, but this time I'm going to be thinking about what the y values are on the graph. So I'm going to start from the bottom and work our way up, right? So my y values keep going down for forever, right? So the range starts at -infinity, and nothing is getting skipped, nothing's getting skipped. I'm coming up along our graph. Nothing's getting skipped. The x values are going left as I'm drawing it in this way, but I'm not paying attention to that. I don't care. I'm just thinking that the y values are still increasing, but it looks like they are not hitting the x-axis over here. And then I go to the other section of the line. And if I look at this section, we can see it keeps going up for forever. And if we start from the top and kind of come down, it's starting up at -infinity, it's coming down, down, it's hitting every y value. It's not skipping any along the way. It comes down, down, and it gets closer. And the y values are getting closer and closer to 0. But again, they're not getting to 0. So 0 is not part of the range. 0 gets skipped. We can have every y value other than 0. And that's where we're getting a horizontal asymptote. So horizontal asymptote. The P is silent. Asymptote. You can kind of like force the B. Asymptote. Asymptote. Kind of just silent the P. Asymptote. Asymptote at y equals 0. So let's talk about what is a horizontal asymptote. And this is a loose definition, but a horizontal asymptote at y equals some number is when, as x goes to plus or minus infinity, the y values stay closer and closer to the number. Right, that we saw above. Okay, and one thing that's really key that people don't realize is okay is that asymptotes can and do get crossed. Okay, this is something, if you saw this in a high school class, they may have said that you don't cross an asymptote, and that's a lie. We can cross asymptotes. We can cross them an infinite number of times. We can cross them over and over and over again, and that's not a problem. So just make a note of that, because we are going to definitely have scenarios as we move forward in mathematics where we cross asymptotes. And so I don't want you to get a sense that we can't cross them. I just want you to think of them really as guidelines. And I'll put that up here. An asymptote of either variety is simply a guideline for the graph. It's not actually part of the graph. So it just helps us draw the graph and understand the graph without actually being part of it. All right, so we've done one. Let's look at this second example here where we've got this function. It's going out to the left, and then it's kind of moving right and up, 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 right around x is -3. And then after -3, it's going down, 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 down. But then as we move to the right, it comes from below and it moves up and then to the right. And it kind of levels out. Never in that section, it stays negative, and then it comes back down, 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 around x is 2. Then to the right of 2, it's shot up to the top, and then it's coming down from infinity. The y values are up at infinity. They're coming down, 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 closer and closer to 0 as the x values move out to the right. So let's do this one a little bit quicker. We have a vertical asymptote at x equals -3 and at x equals +2. And those are going to be our domain restrictions. So domain, that's where the x values don't exist. If I plug in -3 into the function, we would get no output. If I plug in 2 into the function, I would get no output. So the domain is -infinity to -3, along with -3 to 2. Like all of those numbers are okay. Those are in the middle. And then we can also have all the x values from 2 to infinity, but we can't have -3 and we can't have 2, so we're skipping those. The vertical asymptotes, which we can abbreviate as VA, the vertical asymptotes are at x equals -3 and x equals 2. The range, this is actually a little tricky here, and we're going to end up approximating. It's due to this middle section. It gets a little weird. It's hard to see without a computer what exactly is going on here. So let's look at the top chunks first. So we've got, keep my vertical asymptotes in there. There we go. So if I look at the two top chunks, right, this one on the far left and then the one on the far right, they're going up to infinity and then they're coming down towards 0. And it kind of looks like it's hitting 0, but it's trying to indicate that it's not actually touching 0 here. So there's this horizontal asymptote at 0. As x goes to positive infinity, y approaches 0 from above. And as x goes to negative infinity, as we move out towards the left, once again, the y values are going towards 0. But if I zoom in here, we realize that there's a maximum y value in this section, that there's a gap in here, that between the y value at that point and 0, there is no graph. Like there's no line in between there. So let's approximate this point. This looks like -0.5 comma -0. I don't know, let's go 2. 0.1, 0.2. We're just eyeballing this as best we can. So this is an approximation. But we can have this y value. This y value is included. Right? We do reach it. It is part of the graph. But y equals 0 is not part of the graph. We never actually reach that. So the graph goes down to negative infinity, and as we kind of come up from that, we come up to and we hit negative 0.2 as a maximum there, and then we go back down to negative infinity. And then the top chunks of the graph, up top, those go from 0 to infinity, but exclude 0. So this means that the range is negative infinity up to negative 0.2, including that value. I'm going to put approximately since we're approximating at negative 0.2. And then we can have everything from 0 to infinity after that, right? But we skip that chunk in between negative 0.2 and 0. And our horizontal asymptote is at y equals 0. It's not at the negative 0.2. Our graph is not. So the horizontal asymptote is what's happening as x is going out to the sides. It's not what's happening in the middle here. So the only horizontal asymptote is happening as x goes out to plus or minus infinity, what I was noting over here on the right. So we have a horizontal asymptote of y equals 0. Okay. The asymptotes are not about what's happening in the middle of the graph. They're what's happening as either the y values are going to plus or minus infinity, what x values is that happening at, or as x goes out to infinity, what y values is that happening at. So that's how we want to think of asymptotes. All right. Yeah, I think that's good for this video. Nice job, everyone. Go ahead and give the next two graphs a shot, finding the domain and range and the asymptotes for those for the Now You Try problems. And in the next video, we will go through those solutions. Thanks for watching. We'll see you soon.